Chapter 2, Numbers and Sequences. Today we are going to study the topic sequences. Let us go to the definition of sequence. A real valued sequence is a function defined on a set of natural numbers and taking real values. So, sequence is a function f from n to r. N is the set of natural numbers, r is the set of real numbers. Okay, so here every element of a sequence is called the term of a sequence. The first element is called the first term of the sequence. See here, this is an example of sequence 1, 3, 5, 7. This is the first term. This is the second term. This is the third term, fourth term. So nth term, you can say, we can denote it by an. That is the general formula for the nth term. That number value n can be any natural number. It can be 8, 9, 100, any number, whatever you like. Okay. So the nth term is denoted by an. Okay. Let us do some examples. It will be very clear. Find the next three terms of the following sequence. So let us take the first sequence. So let's see. 8, 24, 72. They have given the first three terms, dot, dot. They're asking us to find the remaining terms. Let us now look at these first three terms. You can see here, the first term starts with 8. And the second is what? 8 into 3. That is 24. Okay. The third term is 8 multiplied by 9. And what is 9? 3 square. So here it is. 8 into 3 square is equal to 72. That is the third term. So from when you look at these terms, you can write the formula for nth term. an, that is equal to 8 multiplied by 3 raised to n minus 1. Okay. Now just to cross check, let us again check it. Put n is equal to 1. That will give us the first term. So if n is equal to 1, 1 minus 1 is 0. 3 raised to 0 is 1. So 8 into 1 is 8. So can you see, this is the first term, 8. Now let us go to the second term. Put n is equal to 2 in this general formula. 2 minus 1 is 1. So 3 raised to 1 is 3. 8 3s are 24. Okay. Now let's go to the third term. 3 minus 1 is 2. 3 raised to 2 is 3 into 3, that is 9. And 8 9s are 72. So you can see this is the sequence. 8, 24, 72. The nth term is this. Okay. Now let us find the fourth term. Okay. We want fourth term, fifth term and sixth term. Okay. So let us put n is equal to 4 here. That means it will become n minus 1 is 3. 8 into 3 raised to 3. If you do this multiplication, you will get the answer 216. Next will be n is equal to 5. So 5 minus 1 is 4. So 3 raised to 4 into 8, you will get 648. Now next will be n is equal to 6. 6 minus 1, 5. So 3 raised to 5 into 8, 1944. So the next three terms, see the first three terms they have given. So the fourth term, fifth term and sixth term will be 216, 648, 1944. Okay. So what you should do in these kind of sums is look at the pattern and try to write down the general formula. If you look at this pattern, you can easily get the general formula. Okay. Like next sequence. 5, 1, minus 3, dot, dot, dot. So let us look at the pattern here. So the first term is 5. Second term is 1. That means 5 minus 4. Okay. Into 1 we can say. Because again you look at the third term. It will be 5 minus 4 into 2. So 4 2s are 8. 5 minus 8 is minus 3. See, you got the answer. So this is the pattern, that 5 minus 4 into increasing numbers. That increasing numbers will give us the value of n. Okay. So here the first term is 5 minus 4 into 0. Okay. Put here n is equal to 1. n minus 1 minus 1 is 0, 4 minus 4 into 0 is 0. So a1 is only 5. So here it is 5. Now second term, put n is equal to 2. 2 minus 1 is 1. 1 into minus 4 is minus 4. So 5 minus 4 is 1. See, you got the second term. Third term, put n is equal to 3. 3 minus 1 is 2. 2 4s are 8. So 5 minus 8 is minus 3. So you got the pattern. Now this is the nth term. Now let us find the fourth term. We want the fourth, fifth and sixth. Okay, fourth term, put n is equal to 4. 4 minus 1 is 3. Okay, so here it is. You simplify it, you get minus 7. Similarly, for the fifth term, put n is equal to 5. Simplify this, you get minus 11. Put here n is equal to 6. Okay, so here simplify it, you get minus 15. So the next three terms are minus 7, minus 11, minus 15. Okay, let's go to the next sum. 1 upon 4, comma, 2 upon 9, comma, 3 upon 16, dot, dot. This is the sequence. Let us find the pattern. Okay, 1 upon 4. So let's write 1 upon, this I'm going to write it as 1 plus 1 the whole square. What is 1 plus 1? 2. 2 the whole square. Okay, so this will give us the first term. Second term, let us try to write. So we know that 9 is 3 square, is it not? Okay, so 2 upon 2 plus 1 the whole square will give us the second term. This will be 3 upon 3 plus 1 the whole square. 3 plus 1 is 4. 4 into 4 is 16. So here it is. So what we can say from this? The nth term will be n upon 1 plus n the whole square. Okay, now let's find the fourth term. So put 4 here. 4 upon 1 plus 4, that is 5. The whole square will be 4 upon 25. Next will be 5 upon 5 plus 1 whole square, that is 5 upon 36. 6 upon 6 plus 1 the whole square, 6 upon 49. So the next three terms are 4 upon 25, 5 upon 36, 6 upon 49. Question 2. Find the first 4 terms of the sequences whose nth terms are given. So they have given us the general formula. an is equal to n cube minus 2. Now we are going to find the first 4 terms. Very simple this is. Just put n is equal to 1. Substitute, simplify, you will get minus 1. That will be the first term. Second term, put n is equal to 2. So 2 cube, that is 8, minus 2 is 6. So for the third term, put n is equal to 3 here. 3 cube minus 2 is 25. A4, fourth term is 4 cube minus 2 is 62. So these are the first 4 terms. Minus 1, 6, 25, 62. Let's go to the next sum. So here is the general formula. Minus 1 raised to n plus 1 into n plus 1. Very simple. Don't worry even if it looks very big. Okay, simply we have to substitute n is equal to 1, 2, 3 like that. So let's take n is equal to 1. So this will be 1 plus 1, 2. So minus 1 raised to 2 into 1 multiplied by 1 plus 1. Put n is equal to 1. Simplify this. Minus 1 into minus 1 is 1. 1 into 1 is 1. 1 into 1 plus 1, that is 2. 1 into 2 is 2. 2 is the answer. Okay, let's write down n is equal to 2. So here it is. Substitute n is equal to 2. So 2 plus 1, 3. Minus 1 raised to 3 multiplied by 2 multiplied by 2 plus 1. This will be minus 1. Minus 1 into 2 is minus 2. Minus 2 multiplied by 3 is minus 6. Third term, put n is equal to 3. So here 3 plus 1 is 4. Minus 1 raised to 4 is 1. Into here 3. So 3 into 3 plus 1, 4. That is 3 into 4 will be 12. That is the third term. Similarly, substitute n is equal to 4. Minus 1 raised to 5 will be minus 1, into 4 will be minus 4, plus 5. This is 5. So minus 4 into 5 is minus 20. So these are the first 4 terms. Okay. Third sum, similarly you have to do. Put n is equal to 1. Simplify, you get minus 4. Put n is equal to 2. Simplify, you get 2. Put n is equal to 3. You simplify, you get 12. N is equal to 4. You simplify, you get 26. So these are the 4 terms of the sequence. Find the nth term of the following sequence. So this is the sequence. You have to find the nth term. That is an. That formula you have to write. So first find the pattern here. See, 2 is 1 plus 1. 5 is 1 plus 4. 10 is 1 plus 9. 17 is 1 plus 16. So here you can see 1 plus the square of the next number. 4 we can write as 2 square. 9 we can write as 3 square. 16 as 4 square. So here let's write down 1 plus 1 square, 1 plus 2 square, 1 plus 3 square, 1 plus 4 square. So the nth general term will be 1 plus n square. That's all. Or n square plus 1. Either way it is correct. Third sum, 0, 1 upon 2, 2 upon 3. Let's write down this. These are fractions. So the nth term also will be in term of a fraction. So this is the first term. So this will be 1 minus 1 upon 1. So this will become 0. 0 upon 1 is 0. Here let us write down 2 minus 1 upon 2. That is the second term. 2 minus 1 is 1. 1 upon 2. This will be 3 minus 1 upon 3. 3 minus 1 upon 3. So what is the nth term? N minus 1 upon n. Can you see? Third term is 3n minus 1 upon n. Okay. So this is the general formula. Okay. Next sum, 3, 8, 13, 18. So let's write down. Okay. So 3, how we can write? 5 into 1 minus 2. This will be 5 into 2, 10. 10 minus 2 is 8. This is 5 into 3 minus 2. 5 3s are 15. 15 minus 2 is 13. 5 4s are 20. 20 minus 2 is 18. So this is the general formula. So let's, from this is a general pattern. From the pattern we can write the formula. So an is what? 5n. See, the n values are changing. 5n minus 2. Okay. This is a little difficult, but once you can write down the pattern, you can easily write down the general nth term. Okay. The an is the nth term. Question 4. Find the indicated terms of the sequences whose nth terms are given. So here they have given us the formula for the nth term. We have to find specifically A6 and A13. Okay, A6 means n is equal to 6. So let's write down A6. Wherever n is there, put 6. So 5 into 6 upon 6 plus 2. Can you see? Okay. 5 6 are 30. 30 upon 6 plus 2 is 8. Okay. Simplify it further, you get 15 upon 4. Okay. Let's now do A13. Wherever n is there, put 13. So 5 into 13 upon 13 plus 2. 65 upon 15, that is 13 upon 3. Okay. Next sum, an is minus bracket n square minus 4. We have to find A4 and A11. So let's do A4. Wherever n is, put 4. So this is minus n square. 4 square minus 4. 4 4s are 16. 16 minus 4 is 12. Minus you put it. So this is A4. A11, 11 square minus 14. Okay. Simplify it. You get minus 117. Question 5. Find A8 and A15 whose nth term an is given by this. Okay, these are the general formulas. But here if n is even, we should take this formula. If n is odd, we should take this formula. What this means, n is even. See, the first term, if they ask the third term, fifth term, then we should take this formula because n is odd. Okay. If they ask n values for 2, 4, 6, that is even values, you should take this formula. Okay. So here they are asking A8. A8 is even. So we should take this formula first. A8 is equal to n squared minus 1 upon n plus 3. So here put n is equal to 8. So 8 squared minus 1 upon 8 plus 3. That is 64 upon 11. Okay, 8 8s are 64 minus 1, 63 upon 11. Okay, 8 plus 3 is 11. A15, see 15 is an odd number. So we should take this formula, n square upon 2n plus 1. So write down in place of n 15, 15 square upon 2 into 15 plus 1. 2 into 15 is 30, 30 plus 1 is 31 in the denominator. 15 square is 225. So 225 upon 31 is the answer. Question 6. If a1 is equal to 1, a2 is equal to 1 and an is given by 2 times an minus 1 plus an minus 2. If n is greater than or equal to 3, n belongs to n, then find the first 6 terms of the sequence. So here they have given us a1 and a2. a1 is equal to 1, a2 is equal to 1. Now a3, we are going to use this formula. Okay. So what is a3? 2 into n, put 3. What is 3 minus 1? 2. So 2 into a2 plus, put n is equal to 3. 3 minus 2 is 1. See here. So this formula becomes a3 is equal to 2 into a2 plus a1. Again I repeat, simple I have done for the third term. N is equal to 3. Let us put n is equal to 3 here. It becomes a2 and this becomes a1. 2 into a2 plus a1. And you know the value of a1 and a2. They have already given to us. Substitute. So 2 into 1 plus 1 is equal to 3. This is the third term. Fourth term, again go back here. 4 minus 3 is, 4 minus 1 is 3. 4 minus 2 is 2. So this becomes 2 into a3 plus a2. Again, here in place of n, put 4. 4 minus 1 is 3 and 4 minus 2 is 2. Okay. Now you know the value of a3. You got it as 3. a2, 1. Substitute here. 2 3s are 6 plus 1, 7. Okay. Now a5. Let's put n is equal to 5. 5 minus 1 is 4. 5 minus 2 is 3. So 2 into a4 plus a3. That is a5. a4 we got as 7. a3 we got as 3. So here 2 into 7 plus 3. That is equal to 2 7s are 14 plus 3 is 17. Okay. a6. a6 is 2 into a. 6 minus 1 is 5 plus a. 6 minus 2 is a4. So here it is a5. You substitute 17. 2 into 17 plus a4 is 7. Simplify this, you get 41. So the first 6 terms of the sequence are, write down 1. This is the first term. Second term 1 1 and then 3 7 17 41. So here we come to the end of the exercise. Please go through the exercise once more and practice the sums.